Hello everyone, and in today's video we will be adding to our interaction hierarchy by adding a master door, which means already just off the bat we're making our hierarchy quite complex with multiple masters. But inside this door we're going to set up editable tools to sort the movement in editor, as we can see here. And this way, so all the children doors will have a movement system inbuilt into them where we can kind of change the location of where we want the door to go, like we did last time. And if we see here, we can change how much we want it to rotate on every axis. And we'll just show off. Here we have it moving. And here we have it rotating. And with that, we'll go straight into the video. Okay, right, so to get started, the first thing we're going to do is make a child of our master interact. And going straight into it, we're already going to make our interaction hierarchy quite complex because we're going to add another master blueprint to the mix, which is going to be our master door. And inside of this door is just going to be our open event, but also all the data to actually move the door, so that every child of this master door can open. And we're going to set up some editable variables to kind of control the way that the door opens in the editor. Right, so to start, we're going to have to make our components. So, like the elevator tutorial, we're going to get a billboard and call this start location. And then we're going to get one for our end location. And then we're going to duplicate this once more because we're going to add a new one, which is going to be our rotation route. And basically what we're going to do with this is we're going to rotate this instead of rotating our door, so we control and kind of use this as the axis for the door, so we can control where it rotates from. And we just want to scale this down a little bit because when we're in the editor we don't need it to be this big. Right, and then lastly we're just going to add our door. So we're going to add a static mesh, call it door. In the end result we're going to make it clear, but just for now we want to set up its default location and scale. So we're going to get a plane and we're going to make it work with our door material. So let's see, can we make these? Yeah, I don't think we can make them visible in the editor. So first off, we want to move the door to about here so that our rotation route will be on these hinges, and we want to rotate it to be the right way. And then if we throw it into the world, we can see that it is actually really small. So our scale's off. So we'll just put it in the right place because just make this a little bit bigger, you'll see that as we edit this, it edits it in the level. So that's about the right size. Yeah, there we go. So now we have our default size that we want our door to be. And I suppose we can keep this the same just to have our default door. But do you want to make a note that really, if we click on this, we could edit these to change the door to be however we want it to look. And then we'll just test out that our rotation route works. So if we grab this, then you'll see the door will rotate from the route. And we just edit this by moving around the door, and it will rotate relative to this. And then the other thing we'll do is we'll grab our start and our end location and just try and match them up with where the route was for our door. And this is because really what we'll be doing is we won't ever move the start location, we'll only ever probably move the end location. And this just makes sure that the start location is in the same place, because we can't attach it to the door, because it'll ruin the way our blueprint's going to work, which you'll see later. And with that, we'll get into our blueprint and start coding up how we're going to change the location of the door. Okay, so to start, we're going to make the variables that we need for the location section of our door. So we're going to add a vector, which is going to be our door current location. We'll make this a vector. Our door's target location. And then we want to set the time it takes for the door to move in seconds, which will make a float. And we also need to know if the door is opening. And for this section of the tutorial, these are the 4 blueprints we're going to need. But what we're going to do is, if you see here in category, we can actually make a category by just typing it in, pressing enter, and we'll call this one location. And as you can see now in this drop down menu, we have this location category. And in the time, we want to make this editable because we want to be able to change this in the editor for different kinds of doors. And we'll compile it and we'll set it to 1 by default. Just because when we're quickly testing and we forget to change it, it'll look like nothing's happening. But if it's always set to 1, then it'll move. And is opening is fine. Yeah, in time, we'll call this setup. And this is where all our editable materials go live. And then we're just going to leave is opening on its own because it's going to be used by the location and the rotation, and doesn't really have a specific category that we can put it with. And with that, we can get started. So, first thing we want to do is on begin play, we want to set our target location. And our target location initially is going to be the end. So we'll get the world location. And use it to set our target location. Right, great. Now we want to make our custom event. Call it open. And now any child that we make in this blueprint will be able to call on this event that we're going to make here and use it. So now we also need to set the current location whenever we're trying to open. And for that we need the actual door's world location. Then we want a timeline, which is going to work exactly the same as when we did in the elevator, just a 0 to 1 float track going every second. So if we open this up, make it 1 second long, call it per second, set this to 0, 0, and set this to 1, 1. Brilliant. Great, and we're going to use this timeline to set the door's location. Brilliant. I just add a rewrote there for future reference. So now what we need to do is we need to find a way to move this door towards our target location a certain distance. So we have to do this a little bit differently. So initially we want to get our current location, put that in A, and for our B, we're going to add a vector to our current location. And what we're going to do here is we're going to get our start and end, and we're going to get the distance between the start and end location and find a point along that line. And that's how much closer to the target we're going to move per second. So to do this, we want to get the world location of each. Oh, I doubled it. And we want to make another loop. And so with this loop, we can get any point between these 2 points. So say if we wanted to move 10% closer to our target location every second, we would just set this to 0.1. And if we just wanted to get there in a whole second, we'd set 1. And that's how we get that point. But to do that, to get just the distance, we'd also need to take it off from the start location. But then if we were going from our end location back to our start location, we'd need to do it the other way around. So this time I'm going to plug this in the bottom, plug this in the top. And this is where we're going to use our isOpening. So we're going to get a select vector node, and it's going to pick which vector it needs dependent on if we're opening the door or not. But now we want to be able to edit this so that we can choose how long it's going to take for the door to reach its location. So like we want to get our time seconds and we want to divide it, or divide 1 by our time in seconds. And this is because, say if we just plug this straight into here, say we want the door to move to the location over 2 seconds, we'd have to put 0.5. But if we divide it by 1, it flips it so that we put in 2 to get a 2 second time frame. So it just makes inputting this data a bit more accurate. And so now we've got a condition where the door can move, but right now, say this was 0.1, it would only move 0.1 and then not change. So we need to do what we did last time and have something to check that we've met the target location. But we're not going to put a branch in, we're going to make a new custom event just to make it a lot cleaner, because this is a bit more of a complex blueprint. So here we want a new custom event, and we're going to call this check location. And we're going to create an input this time and call it repeat. And we'll see why we're going to do this in just a second. So here we need a branch. And this is just going to check if the door is close enough to the target location. So we're going to get our door. Get its location. And we're going to see if it equals our target location. And we're going to put in a range of 5, just to make sure. And out from that, first we're going to create another custom event. And we're just going to call this reached location. So if this is true, we're going to say that we have reached the location. And then if it's not, we're going to make another branch. And we're going to create a new custom event called repeat. We're just going to play the timeline again. And the reason why we're not just calling the open event is because here we want a do once node. So that when we've reached the location, the first thing we're going to do is stop, and then we're going to wait for a little bit, add a sequence for some information that we're going to add later, but we're going to stop and reset so we can use the door again. And we just add in the delay to make sure we don't get any bugs where it loops around going back and forth when we don't want it to. Right, and that should be our checker working. So here we want pull on this check location. So whenever we're moving, we're always trying to see if we've reached the target. And when we're finished, we want to do that as well. But we want to be repeating. So that this way, once we've finished our timeline, if we're not at our target, then we will repeat. And then to do a third step, I found that because this is going on a tick, sometimes it goes through the numbers too quickly and it will go past our range without counting it. So a way around that is if we get a sequence here, plug this into one. And we're going to delay. And we're going to check the location another time. And finally, we want to get the world there we go, get world delta seconds, and we want to divide it by 2. And this way, while our tick's going, hopefully in between them, it will be checking the location as well. So that we're checking the location faster than the tick, so that we can get a more accurate result. Right, and now that is the start of our, well, that's our location setup. Oh, wait, first actually we need to do the blueprint for when we've ended, and we need to set up our new location. So here we want a flip-flop. And the first time we go through it, we might need to move this down a little bit. We want to set our target location both times. And we want to set its opening. Also, this needs to be ticked by default. And so the first time we run through this, it's after we've just opened. So we now want to set it to close. And then we will go back, we want to set it to opening. And so when we're closing, we want to go back to our start location. So we'll get our world location. And when we're opening, we go into our end location. Alright, yeah, so now that's everything that should be concerning our location here, and now we'll get into the rotation. Right, okay, so now let's get into our rotation section. So the first thing you need to do is see here, I've made something called an enumeration called door times, and you make this by right clicking, go into blueprints, and we have this enumeration here. So if you create that, and inside of it you'll see it's just a list of names that you can just add and call whatever you want. And we're going to use this as a way to switch between our two different movement types, moving and rotating. So if we go back into our blueprint, we'll now make our variables. So first we want to make a variable that is our door type. We're going to make it editable. When we select the variable, we can actually search for that enumeration. Door types. And that's handy because, say if we pulled it out here, we can plug it into a switch. And as you can see, plug this in here. If it's on moving, it'll go down this way. And if we're rotating, it'll do the code that we're about to do. But first we'll make our variables. Now, as we're rotating, you would think we'd be working with rotators. But today we're going to do something a little bit differently, because in the testing, I've found that there's not as many nodes that work with rotating variables as compared to vectors. And we also get some issues with rotators where our door will rotate the wrong way. And my solution for that is that we're going to work with vectors, and then before we do the door rotation, we'll convert it back to a rotator. Right. So, I'll create a new variable. And this variable is going to be called our door starting rotation. We'll make this a vector. And then we need our door's current location. Or rotation, sorry. And then we need the amount that we're going to be rotating, which is our rotation amount. Or actually we'll call it our door target rotation. Just to make it a bit more uniform with how we've been naming stuff. But that door target rotation we're going to make editable. And if you choose to, I would have, well, we are going to have our door types in setup, but I would also do that with the door target rotation, just so that all of our editable variables are in the same place. Right. So now we need to get to work on applying these switches. So, first one, we'll just make a little bit of space here. There we go, that's a bit better. Drag this back. And so we want to set our current rotation. And we're going to do this by, well, we also want this plugged into play from start. Yeah, we're going to get our rotation root. We're going to get the world rotation. And we're going to split it. And this is because when we split it, both vectors and rotators get turned into 3 float variables. And this is how we can convert them. So now, instead of setting our door current location, we're setting the door current rotation instead. And now we're going to want to do it here as well. I think we're going to have to move this eventually. Yeah, so now if we're moving, we're going to go this way. And we're going to have to drag this way down. And we'll get our rotation root. I'm going to set the world rotation. Then we'll drag this over here. We're going to have to do this line of code again. But we haven't made our check rotation event yet, so we'll leave that for now. And then what we want to do, we want to grab our current rotation. Oh, and we also want to categorize these now, don't we? So we'll just put these both in a rotation category. Yeah, and we want to make a loop. And this, we're going to do a very similar movement method as to what we did up here. And then we're going to want to split and split and drag them into here. Just like before, we're going to add to our current rotation and we're going to plug the alpha in. Right, and then we're going to do our switch a little bit differently. We're not going to do it over here with our rotation, we're actually going to do it in our movement. So we want to get the door starting rotation, target rotation, and if we're not, we're opening. To select the vector, and then we just want to do the same thing down here. Oh, actually, I think I've double pasted that. There we go. And we just want to switch these around. With this being our start point, and this being our end. And then just like last time, we're going to linearly interpolate them based off of how many seconds we want the transform to take place. And then subtract our end from our start to find out our distance. And then we can add that to our current rotation. Brilliant. So now we've found out how to get the distance of our rotation and add it to our current rotation, we need to make our check rotation. Typo. And so here we want to compare the relative rotation of our root, and it has to be relative. I found that when we're doing it with the world, it makes some issues. Just because we're changing the world position, sometimes it can conflict, which we don't have that this time around. And because we're comparing it with a vector, we need to split it and make a vector. Plug it into the x, y, and z. We need to find out if it equals our endpoint, which is this. And we'll leave it to 1 because with rotation it's working with lower values. You can tell when it's, say if it's 5 degrees different from what we want it to be, it's quite noticeable. And so just like that last time, do our initial branch to see if we've reached location, and if not, we need to make the variable here. Yeah, and then the second branch to find out if we need to repeat. And now we just need to plug this in. So check rotation. Here we need to compile first, otherwise it won't show us that variable. So we want it twice in our set rotation block. And now we also need to initiate this switch whenever we finish. Alright, and that should be everything. Okay, and then just before we test, I went back, I tested it, and I realised it didn't work. And so my alternative was that first off, we didn't need to do the switch between two of these. We just needed to do it between the starting rotation and start target rotation to get our distance, because really this is always 0 because our relative root rotator is always rotated to 0, and then the target's only 90. So we never actually need to subtract it to get our distance. It'll just get our distance as is because of such small values, and the starting is 0. So there's nothing like on top of that distance. And then instead of doing the select to switch them around, I figured it would just be much easier to multiply it by -1. And somehow that's made it work. So now if we see currently it's set to rotate 90 degrees, set to 3 seconds. And then press it again to close it. And then if we get our end locations are there, get it a little bit higher. And set our door to moving. You'll see now it moves. And then just have to jump in, do that, and then you see we now have the start of a door that we can both move and rotate. And I think if we just look inside this, actually, I just realised I've added this interact into our open event, but we don't want that in our master. What we want to do, if we compile it, is to actually now get our master door, make a child, and this is going to be called unlock door. And inside of here, we're going to have that event interact plugged into our open. And then in the future, in different ones, we can have things like branches saying, asking if we have a key before we open the door and things like that. But for now, just to have our default door interact open. And with that, we'll get on to the next video. And what we're going to be working on in the next video is just going to be a really simple one, especially in comparison, where we're going to be opening this with a lever, introducing switches to our interactions. And with that, I'll leave the video here. Sorry it was such a long one. It was just there was no way of splitting it up, and there was a lot of information to digest into. And so with that, I'll see you next time.